Good morning and welcome to one of the very fine topic, basal ganglia. There are certain terminologies, say for example, DNS. So in IT, DNS is called as the domain name services. And same abbreviation, it is used even in our medical, right? And that is deviated nasal septum. Now, whether it is a coincidence or what, in IT, if you talk about, say, BG, right, in IT, this is the border gateway protocol. This is a border gateway protocol. One of the toughest, very tricky, right? And same way in medical, the BG is basal ganglia. And actually, in both these cases, whether it is medical or it is IT, once you know these topics, you feel very good, right? So same thing over here. It is only for say this week, right? From next week, it would be as per routine, the Monday, Wednesday, Friday, and Saturday. Okay, so that's the topic for today, the basal ganglia, right? So, and as we know that ganglion, when we said so ganglion, so this means it is cell body, right? Cell body. So over here, it is a group of cell body. So that's how the ganglion is there. Now, same case when we talk about the basal ganglia, right? So this basal ganglia, like yesterday when we were discussing, same style, that outermost is cerebral cortex. And when you remove the cerebral cortex, right? When you remove the cerebral cortex, just the cortex, and you come across this basal ganglia. So technically speaking, if this is the medial part, so our thalamus was over here, then the basal ganglia, and here is the cerebral cortex, right? So this is where the basal ganglia will be sitting. This will be lateral to thalamus, okay? Lateral to thalamus. Now there are certain parts of it. One, we'll look at them, but say collectively, there is one which will be the largest one, right? That is what is called as the caudate nucleus. Right? Caudate nucleus. Then there is one more, which is called as putamen. Putamen. And then third one, this is globus pallidus, right? Globus pallidus. These are the three. Now, when you combine or when you talk about, because you'll see the location of this putamen and globus pallidus, that is together. So together it is called as the lentiform nucleus. It is called as the lentiform nucleus, right? That's what is called as the lentiform. All of them together, that is, they are called as the, all three together, they are called as corpus striatum, right? Corpus striatum. Corpus means body. Sorry. The striatum means something which is strip-like, right? So over here, when you look at these nuclei, they are like strip-like. What about this globus pallidus? Where exactly it is? Now here is the thing, right? See, this is caudate, right? Here, that's putamen. And over here, this is globus pallidus. Now this globus pallidus will be having two parts of it, right? Medial and lateral. Right? This will be having a medial part and the lateral part. Or maybe you can say this lateral will be external, right? This would be external and this one would be internal. So now onwards, we'll be writing it as globus pallidus. When we say I, that means it is internal. When we say globus pallidus E, that means it is external, right? We'll just have a look at it, at how exactly they really are. Now, if you draw a section, right? If you draw a section, so let's say this is the center line. Anteriorly over here, you'll see that that's where the caudate the caudate nucleus will be there, right? Caudate. Then this would be the putamen, and over here, this one would be the globus pallidus. So caudate, putamen, and globus pallidus, right? This is very schematic, but this will tell you so many things. One, all these three nuclei, they are having striated appearance. Right? They are having striated appearance. Basal ganglia is pretty long topic, so that's why we'll divide it into two parts so that we can cover even the radiology part. So you should be able to identify that where exactly is internal capsule, where is caudate, where is this putamen, right? Where exactly is thalamus? Is there anything wrong into that? So that's why today we'll be learning about all these nuclei very properly and then we'll go for the radiology next time. Okay. So these strands, right, they are of gray, right? Makes sense, right? Because they'll be having gray appearance because it is like mostly cell body, right? But if you'll see the globus pallidus, that would be a bit lighter, right? First structure which is coming up. So from caudate to putamen here, right? There would be fibers. These would be fibers, but then just keep in mind there would be one structure and that is internal capsule, right? Internal capsule. We'll see all these things: internal capsule, external capsule, internal medullary septum, external medullary septum, extreme capsule, all of them in the layer one by one. So this is the internal capsule which is located right over here, through which those fibers are passing from caudate to putamen. Right? Now, let's see this. This is as we are watching it from the lateral side. So this is a lateral view. That's the caudate. There should not be any problem in understanding, right? This is the caudate, and this one is putamen. We won't be able to see the globus pallidus, right? This globus pallidus, if we just flip it, that is now this one. This is the medial view, as if we are watching it from inside, right? So this is the medial view, watching from inside. And here is what we start watching. This is caudate. That's the putamen. And over here, this and this, both of them, right? Collectively, they are globus pallidus. So this one is lateral and this is medial, right? And that is globus pallidus. So once again, just for the clarity, globus pallidus plus putamen, right? Globus pallidus plus putamen, that is lentiform nucleus. That is lentiform. Okay. Now let's start watching all of them individually along with their functions. Right? We start with caudate nucleus. So this caudate nucleus, it has got that's head, right? This one would be the body, and that's obviously the tail. Now see, there is a small structure over here, right? This structure, which is called as the amygdaloid body. So it is just lying over there, right? It is not at all part of caudate lobe. Right? But just you can see that this caudate lobe, this caudate nucleus, right? This caudate nucleus will be terminating at the amygdaloid body, though it is not part of it. So regarding why this is such an important nucleus, right? So functions of caudate. Now, before we start with the function, I would like to explain two things. One, there are certain parts of the brain which will be affecting, let's say this is A, this is B. B is very interested in sending the impulses and work, but it is under constant control of A. That means what? A is sending constantly inhibitory signals to B that don't work, remain silent, right? And the result is that B won't be firing anything. But when you stop A, right, for some reason, by any means, you stop A, so this inhibitory signal goes away, right? Inhibitory signal goes away. So in that case, in the absence of that signal, B would start working, right? It will start firing the signals. This is the very important concept, and this is a concept which will be used all the way, even when next time we'll be discussing Parkinsonism disease. So even in Parkinson's, this would be the method. The only thing which we have to remember is that who will be affecting what. So that circuit is what we'll complete today. Right? So here are the functions. The first function, caudate, is critical because it controls classically, right? Classical control of caudate. So what it will be doing, it controls voluntary movement, right? Voluntary movement, and especially the directed movement. It is also called as the directed movement. Directed movement means you know that what you are supposed to do, and exactly that movement should be there, right? It is like if you want to write, so you know that this is how the hands should move. So that is voluntary movement, or the directed movement. This is reason it requires high level of accuracy, right? So this is where the accuracy is needed. Second very important function is executive function. So when you say executive function, that means it is like a decision making, right? It is like a decision making. So this is the process in which there would be requirement of focus, there would be requirement of attention, right? So that is the function which would be carried out by caudate nucleus. The third important function will be, say, when you are working, so this you must have heard, reward and reinforcement. That's the reason that whenever we study, so like sometimes we say bus half an hour and we feel tired, right? So then we go for water, then we have tea or anything. But sometimes, say, let's say if you're watching a movie, watching a serial, right? And literally it happens like one episode, second, third, fourth, fifth, right? One after the another, you finish the whole series in a single shot. Why it happens? That this thing never happens with the books. It never happens with our studies. The reason is that, see, our brain is not understanding that what is good, what is bad. For brain, everything is in the form of reward. So in that story, in that serial, if there is anything which is touching you, right, which is touching your emotions, so that thing will immediately appeal and you will continue to do that work, right? If you can do this thing, think something what is called as the associative learning, right? Something what is called as the associative learning. That means, can you associate any of the things which you learn? If you can, it becomes much easier. What I mean to say is, say, if our 100 rupee currency note, if it falls, if we lose it, right? If we lose it, if it is lost, तो then we feel कि अरे यार नुकसान हो गया. But ठीक है, in your life you'll be able to earn multiple zeros after it, right? You'll be able to earn that much. But let's say if you have wasted just 10 minutes of your life, right? Those 10 minutes, they can never be recovered. So that's the reason that whenever you plan in this way, that any time lost, right, that is like a severe loss. And if you do anything productive which will be having very positive effect, so then you'll be gradually you'll be developing it in the form of habit, right? So this is the third thing, reward and reinforcement. Just duplicate page. The fourth thing, the fourth one, this is associated, or it is linked with, associated with emotions, right? But this caudate nucleus is very specific, right? These emotions, they are not only simple emotions. These are the emotions which are linked with, say, visual beauty, and attraction. So all these physiological phenomena, right, they are all thanks to this caudate nucleus, right? So that we keep on making the hearts like this, right? But yes, this is because of this caudate nucleus. And why we are talking about all these things? Because the moment there will be anything wrong with this basal ganglia, it will start affecting it, right? The next one is still more interesting. This is what is called as the procedural learning, right? Procedural learning. Now, being a doctor, right, all of you have got a huge advantage, because once you know that this is how your brain functions, if you work accordingly, you'll be getting fantastic results. Else it happens like, chalo, we studied something. After 1 week, if a question is asked, to tuta futa we give the answer, but after 1 month, we feel like, I forgot almost everything, right? And then there is frustration. Why it has happened, right? The way these skill sets are, say for example, cycling, right? Initially, you keep on balancing, right balance, left balance, right? There is a fear to fall down, but then gradually you are master of it, right? After that, you don't have to even think about it, and it automatically occurs. Say for example, one of the very complex procedure, how to tie your shoelaces, right? Initially, right, you have to think, okay, this is one loop, and then bend, and right, all those processes, but then it becomes much easier. So these are procedural learning, is that initial part, right? Initial part, you do it very consciously, but then later it becomes like a muscle memory. It becomes completely automatic. So such things, they are thanks to this caudate nucleus, right? Another very interesting thing is, it also stops. What it does, it inhibits certain action, right? It inhibits certain action, but based on what, right? Based on previous experience. Based on previous experience. This is crucial. That's the reason that when we say this experience is a big teacher, sometimes you tell someone that boss, don't do this, right? Still they do it. And then when they get the bad results, so yes, this thing gets registered into the brain. This is that part, the caudate nucleus, right? So any bad experience, so it is avoided in future, right? You must have noted that at times people feel like, chalo, even in medical, right, when the course is so much, they say, chalo, 2 mahine mein we'll finish it. But then when the exam comes, they find that yes, it is so difficult, and suddenly there is transformation. Well, in some cases, so even after exam also there is no transformation. That's a different story. But yes, our brain is designed like that, that if you commit to yourself, right, with the experience, definitely it's life changing. So this is the caudate nucleus, right? So it is, what it tells is that experience teaches, right? Experience teaches. Now there is one very interesting thing, that every time it should not be like self experience. One can learn from others' experience also, right? Others' experience also, it matters. So it will be much easier. Why to burn your hands, right? Okay. So this is the caudate nucleus. Now we start putting that caudate nucleus in relation to other known structures. And this is the all-time great lateral ventricle, right? This is the lateral ventricle, and this lateral ventricle which has got the horns. So this one is the frontal horn, right? Frontal horn. Then this is like parietal. This is atria. This one is occipital, and this one is temporal. This caudate, this one is caudate, right? This caudate nucleus, it is right from the beginning, right, all the way, say it is into the floor. So this initial part, right, that is the head. Sorry, that is the head. This one is body, and this one is sort of tail. So head is into the floor of lateral ventricle, right? This is the floor, this is the floor. So head is, roof of the head is into the floor of lateral ventricle. Then body of caudate nucleus, right? It is just below the body of or parietal horn, or we can say the body or the center of the lateral ventricle. Then it takes turn all the way to the atria, and then finally over here it is into the roof, right? Roof of, tail is into the roof of lateral ventricle, correct? So tail curves and it is into the roof. So this is how they are arranged. Sometimes descriptions, they are so lengthy, but once you see the figure, everything becomes much easier. Okay, focus on this area. That area, this one, this area is called as the nucleus accumbens, right? This is nucleus accumbens. Step by step, we'll keep on adding. So this nucleus accumbens, it is not, right? It is not part of basal ganglia. Yeah, it is close to the head of this caudate nucleus, but it cannot be identified in isolation, right? So it is just like one area. But importance of it is also called as the pleasure center. It is called as the pleasure center. Right? So when you eat something, right, like sweets, or you listen to your favorite tracks, music, all those things, right, they are enjoyed by this nucleus accumbens. So that's why it is said that can it be a part of reward and reinforcement? Reinforcement. Because in brain certain areas they are very doubtful, like colostrum, right? It's very doubtful that what exactly it does, but still there are certain things which are associated with it, so it is believed that it will be doing this. So nucleus accumbens, that is something what is called as the pleasure center, right? So this was about the caudate nucleus. Let's move on to our second one, and that is putamen and globus pallidus, right? So we'll call this thing as lentiform, right? Lentiform nucleus, and lentiform nucleus is combination of putamen plus globus pallidus, right? And globus pallidus has got internal part and the external part. So putamen is what? Putamen is the inferior most part, right? Because this will be in continuous with the head of that caudate nucleus. So that was the caudate nucleus, right? And that's where the putamen is. This one will be the amygdaloid body, right? This is amygdaloid body, and that's the putamen. That's the putamen. Now for the putamen, what we do is we now, if we take a section, right, we start drawing it. This is how we'll keep on constructing it. Three nucleus we talked about. Right? So one, let's say this is putamen, right? Over here there is like globus pallidus. So in between both of them, right? In between both of them, there is, because see, globus pallidus and this is separated, right? So in between we have, in between this. So keep it like this one is medial, this is lateral, right? Just for the reference. So this globus, this putamen, right? Putamen is separated from globus pallidus, and this is what is called as the external medullary lamina, right? Which is just in between, right? External medullary lamina. And when we say external medullary lamina, so there has to be internal medullary lamina. Yes, that would come, right? So this is how it is arranged. Let's take it on a separate page. We draw a full one, right? So this figure will guide you. So this one is, let's say, putamen. Theek? As we go medially, this one is globus pallidus. So we'll just write globus pallidus. We just talked about that this in between part, it is what? It is external medullary lamina, right? External medullary lamina. Then this globus pallidus, we said that it has got two parts, medial and lateral. So let's draw them separately, right? Single shot, we are finishing this part and then we'll go into the details. So this is globus pallidus, this is globus pallidus, right? So this is globus pallidus. It would be external, correct? And this one would be globus pallidus internal, and in between there would be the fibers. So if this one is external medullary lamina, this is what is called as the internal medullary lamina. Internal medullary lamina. Fair enough? Take it like this is lateral and this one is medial, right? These are medial. Now, after this globus pallidus, What is next? There would be centrally situated. It would be centrally situated that our thalamus. Thalamus is there, right? Thalamus. So in between globus pallidus and the thalamus, this portion, that portion is internal capsule. This one is internal capsule. Now, if there is internal capsule, so then there has to be external capsule. Otherwise, we would have named it as just capsule, right? So that capsule is all the way out. Over here, there is a structure like this. It is called as the claustrum, right? This claustrum is very interesting. It is like cerebral cortex, and then this is like a claustrum. It is like wall of the brain, right? So that's the claustrum. We'll talk about it, right? But this is the claustrum. So over here, this portion, that is between putamen and the claustrum. That has to be, so if this is like internal capsule, so that one would be the external capsule. External capsule, right? But then there is one more capsule which is outside it over here, because that's where how it is separated from the cerebral cortex, right? Over here, this is like that. So what name should we really give to this? So very nice. This is external capsule. So that one is called as the extreme capsule, right? Extreme capsule. And then the cortex. So that's how things go all the way from lateral as you enter into the brain. So cortex, there is external capsule. There was, because these medullary lamina, but that's what I'm telling. So these fibers, when we'll be watching that how are they connected, it will start making the sense. Right? So this is how these fibers are arranged, because the function of GPE and GPI, right, it is totally different, as if they both are different structures. That's what when we'll see about all the circuits, right, we'll be learning about there are 5 major circuits. So we'll be learning all those circuits, what is called as the direct and what is called as the indirect. So how this GPI will inhibit all the activity, while GPE, it will excite all the activity. Like just the way to remember. But they don't act. This GPE, it won't be acting directly on the thalamus, but this GPI will be talking directly to thalamus. Right? Thalamus is very enthusiastic, right? It will always send this message to motor cortex कि चलो काम करो, right? It is this GPI will say कि अच्छा शांत, don't be excited, don't do more work, right? So this is like a joint operation of all these structures and all these laminas, all these sheath there which are in between. They are just the tracks, right, on which the signals, they are like the roads on which the signals will be traveling. Okay, so that's how and these are the putamen, globus pallidus, and the globus pallidus, right? External, internal, putamen. That's how they are linked one after the another. Where is caudate? Caudate would be over here. Right? Caudate is over here. Here is the caudate, because it is going all the way anteriorly. Right? So that one would be the caudate. This is a very schematic figure, but it is telling about almost all the parts. Now, what will happen is that as we'll proceed, we'll just have to recollect all these names. Fine. So this is what we have to remember for this particular, say, section. Okay. Next is, so when we say putamen, so when we say putamen and globus pallidus, right? So we said that there is internal capsule, right? And then after that internal capsule, there is thalamus. right? There is thalamus. So this internal capsule itself is a topic, but we'll be taking this topic, that what exactly is this internal capsule, when we'll be discussing all those tracks. So till that point, we just understand that it is a path which will be utilized for the communication. Regarding the putamen, the functions of putamen, one of the major function, it regulates movement. It regulates movement. Things will start going bit tricky as we'll be going into the detail of all these circuits, because we'll find okay, caudate is also working on, say, movement. This putamen is also working on movement. Even this globus pallidus will also be working on the movement via thalamus. But everyone, not only that, then there will be substantia nigra will also come into picture, then subthalamic nucleus will also come into picture, because it's like a joint operation. And every time we say that there would be positive feedback as well as negative feedback. How it works is that, as we discussed, that this is A which is preventing B to work, and B is very enthusiastic. Yes, I want to work, but this A will say, okay, shant, no need to get excited. So it means that if A is stimulated, right? So it won't be leading to any of the motor activity. In fact, it will suppress it, because A is suppressing, it is using GABA. Right, which is the inhibitory neurotransmitter, and it is telling B, don't work, right? So B won't work. But by any means, if you just stop this A, so that means now this particular conduction, it won't occur. So in that case, B would be free, right? And B would act. So all these fine controls, they are by all these various structures. Reason that some of them they are taking active roles, some of them they are considered as modulatory. It is not so that only once the activity starts, it's going on and on and on, right? When we'll be learning about that, how exactly all these, say, even the eye movement, right? When we'll be discussing about that, what exactly is saccade, right? One of the very interesting thing. So, or when we'll be talking about Parkinson's. So in Parkinson's, two things. One, that there is bradykinesia, right? A very sluggish movement, as if in movie, right? They are going in slow motion, very slow movement. And second is tremor. As such, if you see both these two things, they are extremely different. In one case, then that the movement is very rapid, right? But in when it is a voluntary movement, so that is extremely slow. Why it happens? All those things, they are dependent upon this particular circuit, that how the dopamine receptors, etc., they will be working, how substantia nigra, when it degenerates, right, where exactly it works, because these are very fine control. So that's why we are talking about it. Okay, so don't worry, all these things will come. So regulates movements, or we can say that they are like modulators, right? That it should occur very smoothly. But one another important thing about the putamen, is second, that is that all the previous movements, previously learned movements, right? P. So previously learnt movements are preserved. For putamen, previously learnt movements, they are preserved. Movements means skills, right? So if anything is learnt, so then it is preserved. That preservation work is by putamen, right? Okay, moving on to the globus pallidus. Globus pallidus, this is smallest. And we said now that it has got two parts. So all the way from inside out, thalamus, then comes the internal capsule, then comes this globus pallidus. But that globus pallidus will come to this procedural learning, right? It will come. Just wait for a time, right? So, so thalamus, right? Thalamus, and then we have got that internal capsule, right? And then after internal capsule, we have got this globus pallidus internal. Then we have got the globus pallidus external, and here is that in that's medullary internal medullary lamina, right? Internal medullary lamina. So globus pallidus we divide into two parts, GPE and GP. Think it like I is for inhibitory, and E is for excitatory. So when we say inhibitory, it's not so that GPI will inhibit the cortex. Directly or indirectly, this is what we shall achieve, right? Because in circuits, we'll be having the direct pathway, then there will be indirect pathway, all those pathways. These pathways, they become very easy when we learn it this way. So in direct pathway, there would be movement, right? There would be movement. In indirect pathway, it is for restriction, right? We don't want that movement, or it is like when the movement is going on, at that point we want to apply the brakes. The way you drive a car, right? You use the accelerator, you use the clutch, you use the brakes, right? So you use the accelerator and you use the brakes as per need, right? It is not so that through and through for the entire journey we use only the accelerator or we use only the brakes. It is the combination as per need. Exactly the same way these two are path. One path which is telling yes you move, second path is telling stop, right? So out of that, in that entire circuit, this globus pallidus internal and globus pallidus external, they will be coming into picture. To remember it like the final effect, right? Final effect on the body, that would be what? That I, when he comes into picture, he will stop the movement. When globus pallidus external comes into picture, there would be the movement. If rest of the circuit is okay, if there is any problem in rest of the circuit, yes, there would be some disease, there would be some changes. But this is in nutshell, right? So that is the external and the internal part of the globus pallidus. Out of these two, when you compare that if this globus pallidus as compared to say putamen or compared to say caudate nucleus, right, you'll find that it is lighter, right? We talked about it, that this globus pallidus is whitish or it is lighter than putamen. So what could be the reason? Because this is brain. So myelination. You'll find that the fibers of globus pallidus, they are myelinated. And when it is myelinated, so that means it would be white or whitish, relatively white. So that's a very simple point to understand. One more important thing. Remember it like this, because instead of giving you straight away the circuits, step by step, I'll take you to that point. Globus pallidus, right? You said that there is internal and external. So this is like internal. Internal globus pallidus can talk directly to thalamus. And it is actually doing it. And it is sending that don't work, right? Don't work. Now, how can it really say that don't work? That is by inhibitory pathways. Now, in neurons, everything is in the form of neurotransmitter, right? So, where there is inhibitory pathway, on all these inhibitory pathway, the neurotransmitter used, that would be GABA, right? It is what is called as the gamma amino butyric acid. This is a neurotransmitter, but when it will talk to thalamus, it will stop the thalamus, right? So thalamus won't be sending any activity impulse to motor region. So motor activity, that would be eliminated or it would be decreased, right? What would happen when the GPE comes into picture? GPE comes into picture. Now see, GPE tells that I don't want to talk to thalamus directly. It will tell to subthalamic nucleus, right? After just 2 or 3 minutes, we'll be talking about subthalamic nucleus also, because as such we learnt it in thalamus, right? In subthalamus. Okay, by anatomically it is located over there, but use of subthalamus, that is with the basal ganglia, right? So this, when GP is activated, right, so it will tell subthalamic nucleus that, see, you go, right, and tell this GPI, right, not to disturb thalamus. So this subthalamic nuclei will inhibit the GPI. Now GPI was already inhibiting thalamus, so this is what is called as the inhibition of inhibition, right? It is what is called as the inhibition of inhibition. So what happens in that case? Now thalamus is free. Now thalamus is happy. Okay, yes, now I can work, and thalamus will trigger the motor activity. So that's how we say that this GPE, it will be leading to activity. It will be excitatory, right? It will be excitatory, but it is by this indirect mechanism. So actually what we have done is, we have learned, this is called as the direct pathway. Direct pathway, just we have to add few components, and this is called as the indirect pathway. These are the main pathways. Once you have understood it, then your reaction as per the emotion, right? So if we are very happy, to then we smile, we laugh. If someone sad, to then it is something like this. So all these facial expressions, once again, in that also there is direct pathway and indirect pathway. But just remember it like this, that GPI talking directly to thalamus and telling the thalamus, don't do anything, right? Shant. So that's what it does. And when you remove that inhibitory component, inhibition of inhibition, so now thalamus will lead to motor activity. Now, when we say that these are somatotropic means what? That this Putamen, then this Globus pallidus, all these, they are having specific centers as per the body. So different areas of the body, they are represented on this particular nuclei, right? So they will send the signals depending upon where it is required, right? But this is the fundamental. We'll talk more about it. Another concept. And all these concepts, they will be of super use when you'll be diagnosing any of the disease. Because in neurology, right, in neurology, it is the science or the process of elimination. It is the process of elimination which is vital, because only this thing will eliminate, okay, it is, this disease is not there, this could be there, now two possibilities are there, so now this cannot be, so it could be this, it could be that, and then you go for CT or MRI and you go to specific location and you figure out and come up with a conclusion that, okay, it is this, right? So that's how, even when we'll be talking about Parkinson's, when we'll be talking about Alzheimer's or any of the disease, we'll be talking in this fashion. So what now we are watching is that concept for the basal ganglia, right? For the basal ganglia, divided into two parts. One, what is called as the striatum, right? We'll call this thing as striatum. But we already talked about corpus striatum, right? But that's a difference, right? So basal ganglia, over here we write corpus striatum, so that you are not at all confused. When we say corpus striatum, that means we are talking about all three. We are talking about caudate, we are talking about putamen, we are talking about globus pallidus. All three together are corpus striatum. When we say striatum, just striatum, this is also called as the neostriatum, right? This is also called as the neostriatum. And this neostriatum is consisting of caudate and putamen, right? So they are the part of it, caudate and putamen. Right? What about this second part? This is neostriatum, that is called as the paleostriatum. It is called as the paleostriatum, and that consists of only one, globus pallidus, right? Globus pallidus. This first group, that is striatum, neostriatum, that is afferent, right? So this one is afferent. Afferent arrives, and this one is efferent. Afferent and efferent. So this is about these three main. Now, in order to understand the whole circuit, we need to add 2 or 3 more components, right? One of the component which we studied in the subthalamus, right? Now we'll be talking more about it. This is the subthalamic nucleus, right? So during that part, we said, during when we were talking about diencephalon, we said that there is thalamus, there is subthalamus, there is say epithalamus, and then there is a hypothalamus. But at that point, we never talked much about this subthalamic nucleus, because this is anatomically, it is part of diencephalon, right? As such, it is part of diencephalon. But functionally, it is connected to basal ganglia with so many. So that's the reason that it would be better if we now discuss the subthalamic nucleus, right? We'll be writing, because when we'll be drawing the circuit, it would be difficult to write all full names. So that's why we'll be calling this lovingly as subthalamic nucleus. Okay, so this is part of diencephalon, but it has got connections with, right? It connects with globus pallidus. Globus pallidus. And in globus pallidus, we have got two good switches. One is globus pallidus external, and second is globus pallidus internal. So this is the importance of subthalamic nucleus. But what would it do? One word, just in one sentence, if we say prevent, right? Such a fantastic feature. It prevents unwanted movement, right? Unwanted movements. So that's the reason that when anything goes wrong to this subthalamic nucleus, those unwanted movements, they start, right? So this is again a very good modulator, right? It's a very good modulator, very powerful modulator, how it handles. The next one, which we just cannot miss, this is substantia nigra, right? Substantia nigra. Where was it? Well, it was in midbrain, right? In midbrain. In midbrain. This has got connection with striatum. It has got connections with, in fact, corpus striatum, both, right? So this substantia nigra, it connects with neostriatum, and it also talks with paleostriatum. And when we say neostriatum and paleostriatum just for the caudate and putamen, and global, this paleostriatum that is with globus pallidus. Right? This one would be the afferent, and this one will be having the efferent. This substantia nigra, this is actually a true modulator, right? It is actually a true modulator. This function, what modulation is, so when you play video game, right? When you play video game, now if something is like, it's like car race, right? So when you play it on your phone, so your phone tilts on one side, car starts bending on that side, and then you take it on opposite side. So as the road turns, you keep on moving, you keep on balancing it. So that's where, as per the vision, as per the visual, because even this will be part of it, that as per the visual perception, the body keeps on changing it, right? That's why you must have seen that in IMAX theater, right? When though everyone is standing, but when the aircraft starts taking the turn, right? In those IMAX theater, in IMAX, the screen size is so big that your entire vision is picked up. So you feel like as if you are inside. So when the plane rotates, as if the earth is not moving, but you'll see the entire audience will go like this, right? So that's like a feel, because it tells that yes, visually the message is going, though you are straight, right? You are standing straight, but still everyone starts tilting on one side. So this is what it increases or decreases the movement, right? And how it really does, it modulates the basal ganglia, right? Because these two sets, these basal ganglia, they are on both the sides. So both the basal ganglias, right, they are working and they are sending message to the motor cortex, and then the action is occurring right and left. Okay. Next one. So this is substantia nigra. We'll be writing substantia nigra as SN. No, there are two parts, right? But we'll come to that. Amygdaloid body. This amygdaloid body, right, which is on the tip. So anatomically, it is part of this basal ganglia, right? But it is only anatomically, right? Anatomically part of BG. But as such, no, its function is related to limbic system, right? So physiologically, it is associated with limbic system. Plus, when it is limbic system, so it is related to emotion related memory. How important? That's the reason when the memory is emotion related, we go to someone's place, and if that lunch or that dinner is very good, right, and if there is any associated event, we always remember it, right, because emotions are involved. Otherwise, routinely we keep on eating without any emotions. Just even say after 2 days, we couldn't. It is impossible for us to recollect that what was in the breakfast or what was in the lunch. However, this particular party, even after years together, you can recollect that these were the people, this is what we ate, etc. Right? Emotion related memory. When you write, right, even if you scribble, no need to write very legitimately, right? Even if you scribble, you'll find that your ability to remember things that will improve, right? Because you are involving your emotions, right? When you look at yourself. Similarly, about certain that how to really say save your time, and I always say first write it down on the piece of page that this was this is what I did, this is what I did, this is what I did. Then take a red pen by the end of the day and start marking it that this was a sheer waste of time, right? See how automatically you will start improving. Otherwise, everyone is intelligent, right? You are super intelligent and you know that how the time is to be, say, saved, right? But still, we do waste, right? For hours together, people are on WhatsApp, right? Few of the males, when that gentleman is for 3 hours every day on WhatsApp, now that is a crime, right? Being in medical, 3 hours giving to WhatsApp is seriously requiring your attention. Okay. The next one. The next one would be, which we must know, is claustrum. Claustrum, right? So claustrum, we said that it is like a wall, right? Wall of the brain. So there is cerebral cortex, right? Cerebral cortex. And then that's claustrum. Right? So if we really look at it, that what's the function of claustrum, it's very confusing, very debatable thing. But we know one thing very clearly, that basically it is a curved sheet, right? It is a curved sheet of neurons, right? This is curved sheet of neurons embedded in white matter, right? So what is guessed for this claustrum is that when this entire sheath is covering, so can it be because of, say, when this claustrum has got some mechanism that will allow information which will be traveling widely, and this thing can be used for synchronization. So that was the proposal, and then it came that yes, claustrum, it has got very specialized mechanism, right? Specialized mechanism, due to which the signals, they cover large area, right? They cover large area, and this is super interesting and super powerful for the synchronization, right? It is for synchronization, and that synchronization, it is your visual perception, your motor ability, right? All those things which are synchronized, because it is like wall of the brain. So once again, so there is claustrum, right? Then there would be putamen, then there would be globus pallidus, right? But it has got two parts. This is globus pallidus external, this is globus pallidus internal. And after that globus pallidus internal, there is internally the thalamus, right? And we have all the, there is one here, this is one, there is something here, there is something here, and there is something even outside, right? So all of them, they are what? Between globus pallidus and thalamus. So yes, we have got internal capsule, right? Internal capsule. After that internal capsule, this and this, they are the medullary lamina. So we have got internal medullary lamina, which is between globus pallidus external and globus pallidus internal. After that, we have got external medullary lamina. Correct. External medullary lamina. And this external medullary lamina is between basal ganglia, internal part, right? That's between pallidus and between the putamen and the globus pallidus, right? Outside, now that's the time, this is the external capsule, right? So this is the external capsule. And then this is claustrum, and finally, all the way totally out, this is what is called as the extreme capsule. Extreme capsule, right? So basal ganglia, right? Basal ganglia, they talk to thalamus, and thalamus talks to cerebral cortex. So one thing is very clear that for basal ganglia, they pick up information from surrounding, right? It is not coming all the way from spine. So if we really draw it, right, if we really say that, okay, this is the caudate, right? Over here, we have got our putamen and the globus pallidus. The thalamus, right? The thalamus was something like this, right? If we really draw thalamus, we used to draw it like this over here, right? This was the thalamus. So from the basal ganglia, it is given to thalamus, and then thalamus is sending it out to cerebral cortex, right? So this is how it really goes, but then we'll be going for various, they are called as the loops, right? They are called as the loops. It means whatever we learned till this point of time, when we implement it, right? So in basal ganglia, one loop which is called as the motor loop. Today we'll be understanding the difference between all of them, right? Then second, what is called as the learning loop. The third one, what is called as the limbic, which is emotional movement, right? Limbic loop. And the fourth one, that would be the oculomotor loop. Oculomotor loop. So what motor loop is? Motor loop is when we have learned something, right? We have already learnt. So how to do that? And for that, there would be a direct method, that is the direct pathway, and the indirect pathway. So indirect is inhibiting, true? Indirect is inhibiting and direct is working. Indirect, yes, because once we have learnt that if you have to really say, if you go for swimming, right, so you have to swim into your own track. If you drive, you have to drive into your own track. So that is what you have already learnt. When you are learning, that is where the learning loop will come, right? This is when you are learning. So learning process. Learning process. It means that there would be a different set of brain, different set of components which will be utilized. Once learnt, it would be transferred that, okay, now it has been learnt. Now, then it becomes second nature. It becomes easy, right? The limbic loop, that is once again movement, but these are the emotional aspect. These are like emotional aspect of movements. This is where dorsolateral part of the prefrontal cortex that will come into picture, because it is like happy to this, sad to this, right? Then this, then this, right? All those emotions, they are related to limbic system. So it means there has to be some extra component for that. Yeah, it is there. And then regarding the oculomotor loop, this is for the eye movement. This is for the eye movements. In eye movements also, you'll see what is called as the saccado. Saccado is right to left, left to right, right? When you are watching a tennis match, a very high-speed tennis match, right? The concept of fixation, right? Remember the concept of fixation. I would suggest that you should watch one movie, right? This is one of my favorite movie. I must have seen it 50 times. 36 Chamber of Shaolin. You just watch this movie, and in that, the Sante, who is the hero, right? He is undergoing that martial art training. So two wooden blocks, burning wooden blocks, right? They are kept over here, and then the movement starts. So normally our head, when the tennis match, if you are watching, right, you are sitting in the center and then you move your eyes from right to left, left to right at a high pace. After some time, your head will move, right? But that's the training which is given. No, it has to be only the eye movement at a high pace. Normally we don't do it, right? If anything is going, so our eyes, they move very rapid, very smoothly. It moves very smoothly. So that's the difference between saccado and the smooth movement, right? There are various movements which we'll be discussing next time, but this is a rapid movement, the saccado. This occurs only when it is needed, right? But when it is needed, normally we move our head also. In one of the method of what is called as the super reading, right? Super reading. I think there are videos. I have kept it onto my channel. This super reading, what it really does is that when you take a book, right, keep your head steady, and it is your eyes, your gaze, that is moving so rapidly that you start picking up the keywords at a very high pace, and then you start putting those keywords into the form of brain map, and you'll be able to remember the things at a much faster rate, because your brain is not a dustbin, right? You keep on putting all those words, right? So writer, we don't blame the author because he is supposed to write full long sentences. But over here, as you train your brain, I'm not telling you you are training your eyes, yeah? You are training your brain. Your eyes, they are doing just that rapid gaze, right? Without moving the head, you are going so fast, and you pick up the keywords. And then when you arrange them into the form of brain mapping, you'll be able to decipher that particular topic in your own words, and you'll be able to remember it for a very long time. So this is the movement, right? Even if you practice this thing, when I'll say okay, the moment this caudate nucleus will come into picture, this is what really happens. It becomes super interesting, because then you know that even the minor eye movement also makes a big matter. Importance, neurological examination. Someone has come with a case of, say, dementia, right? Dementia, memory loss, right? You observe that is there any saccado, because it is related, right? It is related. So that's the importance of this. So oculomotor loop, right? That is cranial nerve number 3, right? That is limbic loop with the emotions, learning loop, the learning process, right? When you are learning new skill sets, and motor loop when you have already learnt. So next time, what we'll do is, this would be our entire path. First, we'll learn the motor loop, right? Motor loop. Why it is loop? Because it will start with cerebral cortex and all the way, and it will come back to the cerebral cortex, right? That is how it would work. Chalo, let's give you a small example before we close. And so just to you see that how interesting it is. You have to just visualize that okay, all the tracks, they are given names, but we'll try to make it as simple as possible. This is the motor loop, right? This is the motor loop, and we have got the cerebral cortex, right? So here is the cortex. This cerebral cortex will be talking to striatum, right? It will be talking to striatum, not the corpus striatum. It will be talking to striatum. And in striatum, we know that this is what? It is the combination of caudate plus putamen, right? Caudate plus putamen. So this cortex, right? No confusion. This cortex will be sending the excitatory pulse to striatum, right? Excitatory pulse, so there has to be a neurotransmitter for that, and that is glutamate, right? So that is glutamate. So we'll take it like green, glutamate. Now this striatum will do what? Striatum will say, okay, hold on, right? What is going on right now? This is globus pallidus internal. This globus pallidus is talking to thalamus. It is telling thalamus, boss, don't work, right? Don't work. So there is thalamus is telling, fine, I won't work. But thalamus will say, yes, sir, I want to work. I want to go. I want to tell this cortex कि चलो यार start contraction. But globus pallidus will say chup, no, not. So this is what this is inhibitory. So that means it will use GABA, right? So it is preventing any movement, right? It will stop it. Meantime, it is not only the globus pallidus internal. Substantia nigra reticulosa. Substantia nigra reticulosa, right? There are two parts of it. So this is Substantia nigra reticulosa. He is also the brother of globus pallidus internus. He is also doing the same thing, but the only difference is doing the fine work, right? Modulation. It is doing the fine work. So both of them, they are connected to the striatum. This is also doing the same work and telling the thalamus, don't work. Now, because here the striatum is directly connected to globus pallidus, and these are like, say, caudate, putamen, globus pallidus, right? Globus pallidus, all of them, they are our basal ganglia, right? So it is this gang which is telling the thalamus what to do and what not to do. Now, when the cortex tells that yes, we want to work this particular striatum, right? This particular striatum will release GABA, and on those channels, it will stop globus pallidus internus, right? So this is where the GABA will come, gamma aminobutyric acid, right? So which is an inhibitory neurotransmitter. Same thing would happen over here, right? Even this substantia nigra, right? That one will also be stopped. So the moment it happens, right, this inhibitory component is out, right? Inhibitory component is out. So this is like a stimulate, right? This inhibitory component is out, right? Now there is no one to stop them. That path itself is down. Thalamus now goes into the excitatory state and it will release on these channels the glutamate, right? That's where the glutamate will come into picture and will lead to contraction of muscles, because that's where the cortex will work and then muscle contraction will start, right? So this is what is called as the direct path, right? It is called as the direct path, right? So direct path is for the movement, right? Direct path is for the movement. Now same components will be used, right? But things would change. Now before that, a small understanding that when we talk about globus pallidus, when we talk about this putamen, right? We talk about putamen. In globus pallidus, there is external, there is internal. To say so, it is just like a strip, na? Right? They are just like small strips, right? This putamen is also like a strip. But on this strip, the way we must have seen this, that okay, this is the cerebrum, right? This is the cerebrum. So then there is nose, big nose, then these eyes, cheek, the whole face is represented on this big. Then hands, they are represented into the form of big areas, right? Rest of the areas, they are very small. But face, right? But the face, hands, right? They are occupying a large area. Same principle even in case of globus pallidus and the putamen. these are the areas, because say with facial expression, so many things can be done. Your hand, they can do so many things. In robotics, the most difficult thing is to make the hand, right? Most difficult thing, because one servo motor which is kept, but if it is to be very powerful, so then it won't be picking up the rose like that, right? Your hand can give a punch, your hand can take a rose, huge move range. Same thing over here, right? Same thing over here. Here the body parts, they are represented very discreetly, very properly. That's the reason there is a word called, it has got somatotropic distribution. So when you come across this word that there is a somatotropic distribution, that means this particular nucleus, the whole body is mapped on it. But that mapping, it depends upon how much is needed. So definitely hands, they will be getting much bigger area as compared to back. For back, so there might be a very small putty, very small strip, right? Face will be covering a huge area, because when we'll be learning about that limbic loop, right? That why it happens, that when the person is sad, so then it goes like this, right? For a kid, when the kid is happy, to why that kid smiles, right? How that smile becomes automatic, right? All these things, they are so vital, because automatically you will be learning one of the very fantastic thing, and what is called as the body language. No doubt, body language itself is a very specialized topic. But if you understand this, and then if you wish, I can send you the PDF about this body language. Superb skill sets, right? So, but no doubt, it has got nothing to do with exam. This is just for the hobby. But yes, it is one of the very interesting science. Exactly the way the thing what is called as the graphology, the study of handwriting, right? Just a signature is enough to know so many characteristic of the person. And in case if you come across this book, right? This is one of the best book. This is like graphology and graphotherapeutics. Graphotherapeutics by Paul the Sainte Colomb. What it really tells is graphology is the study of handwriting, and graphotherapeutics is that how can you change and improve your characteristic, improve your abilities by changing the handwriting. So this is like a therapy. It's like a therapy. Fantastic book, right? But it's in very short supply. So but it's a thick book, right? It's like Harrison. Okay, so this is what we were talking about, that it is the somatotropic distribution, right? Acha. As we have talked about direct, so let's finish the topic with indirect. So this is now indirect loop. Indirect loop for motor, right? Indirect. Why to strain ourselves? I is for inhibition, right? I is for inhibition. So this means this loop will do what? Say if only the excitatory part is working, so then the movement starts, but it won't stop. This is where we will learn how the movement is to be stopped. So movement can be stopped. One principle, that thalamus is to be told, boss, don't work, right? So thalamus would say कि ठीक है, मैं तो सिर्फ दो जनों का कहा मानता हूँ. That is what? Who are they? GP internal, right? Globus pallidus internal and substantia nigra reticulosa. Only both of them, they say, if they say ठीक है चुप, don't work, thalamus would say कि हाँ, I won't work. Let's draw that thing, right? Let's draw that. So here is the cortex, right? Instead of cramming, what we do is we do the reverse engineering, and so it becomes much easier. So here is the thalamus. What do we really want? The final output, we want this, right? That thalamus is we are painting it red. That means it is the inhibitory movement, right? If the movement is occurring, stop it, right? This is what we want thalamus to do. Thalamus will listen to substantia nigra reticulosa, and our GPI, I for inhibitory, but over here I is for internal. They both will do dadagiri on thalamus, so they should be telling that you stop working. So that means both of them, they should be excited, right? They should be sending the message, right? They should be told that yes, you work. So that means the circuit which is just before that, it has to be positive. It has to be positive. It is exactly like these are gundas and you tell gunda, ja jaake maar ke aa, right? So it means you are telling gunda ke are ja ja go, right? And then he goes to the thalamus and chal baith ja, kaam nahi karna. This is what really happens. Now, so there has to be one bigger boss than that, right? And there comes our subthalamic nucleus. Till this point, the subthalamic nucleus was sitting silently. It is this subthalamic nucleus who will be taking the supari, right? Who will be telling that, okay, I'll tell this, both of them. But who will be doing it? And here comes GPE. Now this is GPE, right? Under normal circumstances, this GPE will be telling this subthalamic nucleus. Under normal circumstances, right? Normally, this GPE will tell that, see, be a good child, STN, don't be, say, troublesome to anyone. So this GPE, right, this GPE will be preventing STN to do anything, right? Because this GPE is, it prevents normally, right? Normally it prevents STN action. STN action. So this is normally. So when STN is not telling anything, so this substantia nigra and GPI, they are also sitting silent. They are sitting silent. So thalamus is like working and the movements are going on. But when it is to be restricted, right, this GPE, because he is big boss, he can tell that STN don't work. This striatum comes into picture. Striatum, right? This striatum. That is when cortex tells, because cortex will always be sending, say, excitatory, right? But this striatum decides, striatum, that we have to stop this movement, right? We have to stop this movement. So tell this GPE that is gunde ko khula chhod do. So then this, how this is done, sorry, not this, red. It tells GPE, don't work, right? You remain silent. When he remains silent, that means this particular track is closed. It means now this STN, it is in full form, right? He tells that jao, substantia nigra and GPI, jaake tell thalamus not to work, right? And that leads to this inhibition of the movement. Still, one more thing, this cortex, that is super smart. Cortex tells that let me do one thing. He goes and he talks to this subthalamic nucleus directly. कि यार you are such a powerful person, right? तो यार ये movement बंद कराओ ना, right? This thalamus is sending those signals and I am doing so much. So he talks directly to this subthalamic nucleus. So subthalamic nucleus, now he is so happy because cortex is telling कि जाओ, You go and work, and his big boss, right, GPE, till now he was telling no, you don't have to work, you don't have to work, right, chup baitha rahe. Now there is no one to tell him. So this path is clear, and someone is telling ke ja ja, and then the whole thing works. This is what is called as the indirect loop. Direct loop and indirect loop in nutshell. And still there is a still finer control, right? On top of it also there is these are the dopamine receptors D1 and D2, right? Which will be, chalo, let's discuss that part also, right? It is, so it will complete the topic. So we have got direct and we have got indirect, right? Indirect loops. So this direct loop is for movement, right? And this indirect movement is to restrict, right? Finally, so everything is going via that thalamus only. There is one more path, and this path, right? This is like what we learned. We are adding a new path that is called as the, sorry, very easy name, substantia nigra to striate. So it has to be nigro striatal pathway. Just the name itself is sufficient, right? Name itself is sufficient, because when we say that, see, this is substantia nigra and the striatum, theek? So here the substantia nigra, but not that reticulosa. Here it would be compacta. So compacta. So substantia nigra has got two parts. One, substantia nigra reticulosa, but this substantia nigra compacta, that is which is talking to striatum, and it has got language. It has got language of dopamine, right? Now dopamine, it acts. Now this dopamine will prevent or it will inhibit. Well, depends. It depends. How it depends? Say there are two types of receptor, D1 receptor and D2 receptor, right? So dopamine to chalo is released, right? The dopamine would be released, but the receptor, one receptor is stimulatory receptor and another receptor is inhibitory receptor. So when you want to control the direct pathway, right? So this is like for the direct pathway, right? So this thing would affect, we'll just have a look at the circuit also. Direct pathway, so D1 will be stimulated, right? D1 will be affected, right? D1, because it has got the stimulatory effect, right? For D2, right, it will be having inhibitory effect. It will be having inhibitory effect. So this is for the indirect path, right? They will be affected. In reality, what happens? In reality, say this nigrostriatal pathway, right? This dopamine pathway, it can act here, it can act here. But it will be working in such a way that, see, the normal pathway is working, right? If there is more movement and you want to restrict that movement, so it will tell indirect pathway ki chalo control karo, right? So it would be a balance of direct and indirect. Directly those two pathways are working. On top of it, this nigrostriatal, that is entering into picture, and that's why it is called as the modulation. This dopamine is for the modulation. And what happens in Parkinson? This is the mechanism which fails. This is the mechanism. So when you move your hand, it is so smooth, right? But this is because dopamine is handling that, okay, at this point, stop, right? Move, stop, move, then back, stop, move. So at this mechanism, it goes such in an intricate way, in a very balanced way. But when this modulation, this fine control is lost, so then it goes like this, because then that movement, right, which is the movement, which is the direct pathway, it is moving, but there is no one to control it, right? There is no one to control it, and that is what is called as the tremor, which happens in Parkinson's. Because in Parkinson's, the substantia nigra is damaged. So when the substantia nigra is damaged, this dopamine, right, that goes out of the picture. So this modulation goes away. And this is the problem. Second, in Parkinson, when what is called as the bradykinesia, right? Person moves so slowly, right? He moves, even if it is eating, so it is like, actually it goes like that, right? So slow because of the lack of this modulation, right? When the direct pathway is affected, so that substantia nigra which was sending the message over here, right? Substantia nigra is substantia nigra. This one, right? Where is it? Where is it? Here it is. Substantia nigra, right? Over here, affected, right? So this leads to tremor, and when it comes to over here for the indirect pathway, this substantia nigra, which was who was supposed to tell thalamus ki boss stop working, but when he himself is damaged, right, when he himself is damaged, so then that signal won't be going that strongly. So that thalamus would not be told that strongly ki bas chup stop, right? So some movements they will keep on occurring. So this is the reason that when it comes to just let's add one more page, duplicate page. Yep. So in nutshell, substantia nigra is damaged, dopamine, right? Dopamine is affected, and for the direct pathway, when the direct path is involved, that will lead to tremors. Indirect pathway is also involved, indirect pathway. So then it would lead to bradykinesia. So in one case, those uncontrolled movements, and in second case, those sluggish movements, right? That is what leads to this. And this is the basis of Parkinson's disease. So next time we'll be talking about this, plus we'll be talking about other pathways, right? Other loops, learning loop, oculomotor, right? What really happens in the limbic loop, right? When it is associated with emotions. Then we'll be watching a few of the cases, right? CT scan and MRI. So that would be in our platter for the next time, right? So I'm saving this thing into our folder, right? Shared folder. Thank you so much. And from next week, it would be as per routine, Monday, Wednesday, Friday, and Saturday. Okay. Thanks a lot and see you soon. I'm putting this file into our folder. Thank you and bye-bye.